Hi everybody, welcome to section 2.4, division with fractions. And division with fractions is really simple. How do you divide two fractions? So before we go into it, remember what a reciprocal is. So reciprocals are also known as multiplicative inverses, okay? So they're two numbers that their product is 1. So let's say, for instance, 3. If I multiply 3 by 1/3, I would get 3 over 3, which is 1. Okay? So basically, any number times its reciprocal is going to be that number over itself, which is 1. So the reciprocal, you can think of it as, basically we switch the numerator and the denominator, if you want to think about it in an informal way. So 2/3, the reciprocal of 2/3 would be 3 over 2. The reciprocal of 4/5 would be 5 over 4. The reciprocal of 5 would be 1 over 5, since 5 is 5 over 1. The reciprocal of 1/6 is 6 over 1, which is just 6. And 0, what would 0 be? Well, you cannot divide by 0, so 0 does not have a reciprocal. Okay, because how can you multiply a number by 0 and get 1? That's literally impossible, right? So 0 does not have a reciprocal. Okay, so division by a fraction is the same as multiplication by its reciprocal. And then it says here, C type. Okay, I wrote a note to myself and then forgot it. So on page 130. So here's some examples. So let's say we want to divide 1/2 divided by 1/4. All you need to do is flip the second one. They say keep, change, flip, right? That's another way, right? 4 over 2, which happens to be 2. Okay. Let's do another one. How about 1/30 divided by 1/60? This is division, 1/60. So keep, change the sign, and then flip, right? So then that becomes 60 over 30, which is just 2. Okay, that's also 2. Interesting. How about, let's do another example. 3/8 divided by 9/4. Okay, so keep, change the sign, flip the second fraction, and you will get 12 over 72, but that reduces to become 1 over 6. Okay. And that's, let's do another one. More fun examples. The quotient of 8/3 and 1/6 is decreased by 5. What is the number that results? Okay, so the quotient of 8/3 and 1/6 is increased by 5. So then we would have to do this first. 8/3 times 6 over 1, and then add 5 to that. So then that's going to be 16. So you get 16 plus 5, which is 21. Okay? And how do I know that this is 16? Well, this is 48 divided by 3. That's one way. Or 3 goes into 6 2 times. 8 times 2 is 16. Okay? Okay, so let's, since we still have a bit more time, let's go ahead and continue into section 2.5, okay, which deals with addition and subtraction with fractions. Okay, so let's consider the case with equal denominators. So let's say we want to add 1/2 plus 1/2, right? So we keep the same denominator, and it becomes 2 halves, which is 1. Okay. So for A, B, and C not equal to 0, so let's say you have A over B, like A over C plus B over C. So in general, if you have two fractions that have the same denominator, all you have to do is just add across the top and the denominator remains the same. And then subtraction is the same thing, except of course we're subtracting, right? So that's the rule. Okay, so it says, now you try examples 1 through 4 on page 138. So that is, let's go ahead and do some together. So we have here, let's find the sum or difference. So number 1, let's do on the practice problems on the side. So 3/10 plus 1/10. Number 2, a plus 5 over 12 plus 3 over 12. Number 3 is 8/7 minus 5/7. And then number 4, which is 5/9 plus 8/9 plus 5/9. Okay? So if you want, you can go ahead and pause and then do these, and or just wait and we'll do them together, okay? So 3 plus 1, so all you have to do is just add across the top, so that's 4/10. We reduce this, becomes 2/5. Okay? This one is A, this is the letter A, not the number 9. A plus 5 plus 3, the denominators are the same, so that's just A plus 5 plus 3 over 12, which becomes A plus 8 over 12. Okay? And then this one is just subtracting, so 8 minus 5 is 3 today, so that's just 3/7. And then here 5 plus 8 plus 5, that just becomes 18 over 9, so then that is 2. Okay? Awesome. All right, next thing, we're going to talk about what if they are different denominators. So first of all, let's talk, what is the least common denominator? So the least common denominator for a set of denominators, least common multiple, right? It's the multiple, it's the number that is exactly divisible by each number, right? It's the smallest number, because it's the least common. It's also known as least common multiple, right? So find the LCD for 12 and 18, right? So let's see, what would the least common denominator? So I want 12 and 18, okay? So I know that 12, what are the multiples of 12? 12, 24, 36, right? 18 is, oh, there it is. Sorry, this is 36. These two are in common. It's the least common multiple. But how do I get 12 and 18 to have the common denominator of 36? Well, I'm glad you asked that. So if you have 5 12s, I'm going to do this vertically so that it can be more obvious, plus 7 over 18, right? I want to do this, but I can't because their denominators are different. So I know by finding this out that the ones that they have in common are 36. I can do something to them to change the denominator to become 36. So in this case, I can multiply top and bottom by 3, that's allowed, and rewrite 5 12s as the equivalent fraction 15 over 36. And 7 18ths, I can multiply top and bottom by 2, and I would get 14 over 36. And now, oh ho ho, we have the same common denominator, and we can add across the top, giving us 29 over 36. And that is the answer to that. Okay? So let's do some more examples. What would be the LCD for 3/4 and 1/6? So 4 and 6, right? We know that 4, what are the multiples of 4? 4, 8, 12, 16, and da-da-da. 6 would be 6, then 12, then 18, but that's all I need. I notice that the common multiple is 12, okay? So again, so 3/4 plus 1/6, I know that I need to find equivalent fractions with the common denominator of 12. So this is going to be 12, this is going to be 12, and I'm asking myself, okay, 4 times what gives me 12? Times 3, but I have to do both, okay, so that I can find the equivalent fraction, okay, and then this one I have to multiply top and bottom by 2, and that just gives me 11 over 12, and that is it. 9 plus 2 is 11 today. Okay, great. So rules for adding and subtracting fractions. Okay, So first thing we need to do is we need to find the LCD, right? We can do that using factoring, or we can write the multiples out like how I did. We rewrite each fraction as an equivalent fraction, right, that has the LCD as its denominator, okay? And we add or subtract, and then we reduce to lowest terms. Super fun, now you try. Okay, so what if we have 1/6 plus 1/8 plus 1/4? So let's go ahead and do the prime factorization method, okay? So you have 1/6, sorry, I'm going to start from the beginning. 1/6 plus 1/8 plus 1/4, and I want to add these, okay? Now let's go ahead and factor each one and see what we can find. So this is 1, 2 times 3, right? 1 over 2 times 2 times 2, and then 1 over 2 times 2, okay? So we want to get these to have the same denominator, okay? So I know I have 2 2's. I need to at least have 3 2's and a 3, okay? Because all of these have to divide. They have to be rewritten with the same 1. So you can't take anything away. You can't take any factors away, but you can multiply it by 1 and introduce a new factor. So in this case, the highest number of 2's is 3. So I'm going to need another 2 and 1 3, top and bottom. Okay? Now on this one, I have the 3 2's, but I need a 3, so I'm going to multiply top and bottom by 3. And then this one, I have the 3's and I have one of the 2's, but I need 2 of them, 2 2's. So I'm going to do that. So this way, 2 times 2 times 2 times 3, that gives me what? 24. And on the top is 6. Okay, then here, 2 times 2 times 2 times 3, that's 24. And then on the top is 3. And then on the bottom, see how it's 2 times 2 times 2 times 3, that's 24. And on top is 4. Okay, so now I can go ahead and do that. So that's going to be 13 over 24 when I add. Okay, now the other way, let's say if we had done it the other way, so it's very similar. So 6, 8, and 4. We would just go ahead and list 4, 8, 12, 16, 20, 24. This one would be 8, 16, 24. This one would be 6, 12, 18, and then 24. And so you see that 24 is the common multiple, okay? So we would get the same thing, and we would pretty much do this, okay, except it wouldn't be as broken down, okay? Alright, so let's do a subtraction problem. What if we wanted to subtract 3 minus 5 over 6? Well, here, it's the denominator for 3 is 1, so we want to have the same denominator, so I'm going to multiply top and bottom by 6. So what really this is 18 over 6 minus 5 over 6, and that becomes 13 over 6, and we're done. Okay, and then let's go ahead and compare fractions. So in order to see which is larger, let's rewrite the fractions as equivalent fractions with the same LCD. Okay, so let's say we wanted to write from smallest to largest, and we have 8, 16, 4, and 2. So actually, I believe that 16 is the least common denominator for all of these, right? Because 4 divides it, 2 divides it, 8 divides it, and of course it divides itself. Okay, so let's rewrite this. So we have 5 eighths. Let's rewrite this as a 16. So that's times 2 times 2, that's 10 16. So this one is 10 over 16. This one stays the same, 5 16ths. 3/4, let's go ahead and write that as the equivalent fraction for that. That's 12 over 16ths because 4 times 4 is 16, so multiply the top as well. And then 1/2, rewritten as a fraction with the number 16, we multiply top and bottom by 8, so that gives me 8 over 16, 8 over 16. So now we need to write it in order from smallest to largest. So now it's easy because they're all the same denominator. It's 5, 8, 10, 12, right? So it would be 5 16ths, right? And then it would be 8 16ths, or you can write it 1/12, 1/2, 8 16ths, and 10 over 16ths, and then 12 over 16ths. And then if you wanted to write it in lowest terms, we would just go back to what we started. So it would be 5 16ths, 1/2, 5 eighths, and then 3/4. And that's it. Okay? Alrighty, and then your homework for both of these sections, super fun homework, is 1 through 51 every other odd. And for 2.5, it's 1 through 57 odd, 63 and 64. And I keep forgetting the secret word, but this time the secret word is Mozart. Because that's what my son is learning in the background. Okay, I will see you guys on the next video. Good luck and happy studying.